Be honest, how many times have you opened one of your old Python scripts and thought, this is ugly, inefficient, and I hope nobody else ever sees this? I've spent 25 years in data engineering, and trust me, I've written plenty of that kind of code myself. Here's the thing. At scale, messy code doesn't just look bad. It slows pipelines, it burns compute, and it costs real money. In this video, I'm going to walk you through 5 real-world examples of bad Python versus better Python for data engineers. If you can spot and fix these, you will write code that runs faster, is easier to maintain, and earns the respect of your peers in code reviews. These are the habits that separate juniors from engineers who look senior. Let's start with building data frames. We're starting here with ingestion. I still see people building data frames row by row. That is so painful to watch. Bad code, these are loops that append row by row. Every loop is reallocating memory. On a small file, that might be fine, but on a 100 meg CSV, you're going to be watching it crawl. A better option is to use read CSV once. Read the whole CSV in, pull in only the columns that you need, set the data types up front, parse your dates on the way in. That single change is the difference between waiting seconds and waiting minutes, and for millions of rows, even longer. Here's the tension point. If loops are a bad idea for ingestion, what about when you actually calculate metrics? For example 2, we're looking at row-wise apply. Dot apply, it looks clever, but in reality, it kills performance. Here is an example of some bad code where we're using df.apply with a lambda that is multiplying quantity and price. It's handling discounts and tax, which is important to do. It works, but it is a Python loop that's pretending to be pandas. Better code? Take a look at it. Do the math. Vectorized, using fill-NA to handle missing values, multiply the whole columns all at once. Don't loop over and over again. This runs at C speed under the hood. And here's the proof. On a data frame with 10 million rows, .apply can be 100 times slower than vectorizing math in this example. That's the difference between waiting 10 minutes and waiting 6 seconds, or even milliseconds. Fixing this levels you up into more efficient pandas usage. But if you want to see real power and see what that really looks like, stick around for next week's video where we take these same principles and upgrade you to Spark. List membership. Now let's talk filtering. This one gets sneaky. Here is the bad code example. Here we're using isIn with a list of allocated SKUs, right? On the surface, this looks fine, but lists check things off one at a time. That, if you paid attention to our O notation video, is one of those O notations that cost you more money. A better code example is swap that list in for a set, or better yet, do a merge join against a whitelisted data frame. Why does this matter? Because a filter that runs in minutes with a list can run in seconds with a set or a join. Here's a caution though. Mistake warning here, pay attention. Make sure both sides of the join are the same data type. If one's object and the other one's a string, you're going to silently miss a bunch of matches and absolutely destroy your data set. Example number 4, aggregations. Here is one that I see constantly. Manual aggregation with loops. Here's a bad code example. Here we're iterating through rows, tallying orders, adding up revenue. It works, but man is it ugly. And worse, it thrashes the interpreter. Here is a better code example. Here we're using GroupBy and Agg for our aggregations. Use named aggregations so that the code reads like a spec. This is so much more maintainable and so much easier to read, right? One pass, compiled operations, readable in a code review. Again, so much more maintainable. And here's the outcome. What used to be 50 lines of loops can collapse into 5 clean lines. That's fewer bugs, faster runtime, and way easier to maintain. Beware of this mistake warning again. Don't reach for GroupBy apply unless you absolutely need it. It usually is going to be killing your performance, and you just got them back from the aggregation. Example number 5. Here we're going to touch on Spark real quick. Spark UDFs and Collect. This is the last one, and this one is absolutely killing your cluster right now. Bad Spark code. Here is that example. Collect a dimension table to the driver, use it in an is-in, and calculate revenue with a Python UDF. It runs, but not for long. Collect is dragging your data back to the driver. Python UDFs are serializing row by row. Your executors are grinding to a halt. Here's a better example. Use a broadcast join for the small dimension. Stay with built-in Spark functions for the math, and handle nulls with coalesce. This is JVM native. It is execution parallelized with no driver bottleneck. And the payoff, pipelines that actually finish without your cluster screaming for more nodes. Mistake warning here. Only broadcast truly small dimension tables. If it's big, you are going to crash your executors. Big dimension tables, don't use this method. Quick recap. 5 fixes. Stop building data frames and loops. Stop using apply for math. Stop checking membership and lists. Stop writing manual tally loops. And stop writing Spark UDFs when built-in functions exist. Every one of these changes makes your pipelines faster, cleaner, and more professional. They also make your code reviews a lot less painful and don't make you want to puke in your trash can every 6 months when you look back at your old code. Here is what you want to do next. Take one of your production scripts, refactor it with these fixes, then measure. Be sure that you keep track of what your efficiency gains are and use those in your next review to get a better raise. I also put together this free guide. I called it Clean and Efficient Python for Data Engineers, 10 Quick Wins. Grab it down in the description. Keep it open while you code. And if you want to see the same bad versus better mindset and how that applies to SQL, watch this video where slow queries don't just waste time, they waste money.